All right, let's get started. Welcome to the December 2022 OpenZFS leadership meeting. I see a couple of items on the agenda. I don't think I have any announcements, so let's get started there. First one, Unmapped prefetch review request. Is that you, Alexander?
Yes, it's me. Just started. I already announced it in chat and personally to a few people, but last week I completed an Unmapped prefetch PR, which I started during the Dev Summit hackathon. It appeared bigger project than I originally hoped, but patch appeared to be not bad, but it's based on much more invasive ARC cleanup. So it's not exactly trivial to review, other than it's in two separate patches, but I'm not sure I can split it smaller chunks. But I think both are good to have because that code is pretty old and needed cleanup anyway. And the final result I got with it is pretty amazing as for me. Like if somebody don't need compression and don't need much of data cache hits during sequential operations, and this patch practically doubles read speed. From one point, it reintroduces prefetch, which was for many years disabled for uncached data, if you set primary cache to metadata. And second, it avoids one memory copy out of two. So instead of copying data from ARC to debug cache and from debug cache to user space, now it maps directly buffers from ARC to debug cache. Since we know that buffer will be evicted very quickly, we don't need to use ABD for that. And since it's uncached, we can just map the buffers directly. And that's only one memory copy. So I was, instead of 2 gigabytes per second, I got 4 gigabytes per second, which is practically the speed of single memory copy in one stream.
That's great.
So, yeah. And same happens for write, just for write, it's happened on different thread. So write performance is about same, 4 gigabytes per second, just with lower CPU usage. Like again, instead of 2 memory copies, only 1. And it's very like relatively small and clean patch comparing to alternative ODirect patch, which is much more invasive, I think. But I think they could coexist together. Like if people who want to use completely zero copy read or write, they could use that ODirect patch in between. I think this patch could also be mapped to ODirect. Just maybe some property could switch which of ODirects should be used. And obviously that ODirect zero copy one can be used in some situations, such as requires aligned buffers and other things. So maybe when it can't do the things, my patch could do the things. So I think it would be a good part to complete the picture. So I'd like to ask for testing and reviews. So it passes the tests, and I did my tests. That's kind of all I can do for now.
Cool. And just to make sure I caught it, and for folks who maybe need a little TLDR, the improvement here is when you have set the primary cache to not include the data.
Yeah, primary cache metadata, that's probably the most realistic
Then
case.
primary cache metadata, and then you're reading a file sequentially, and so it's being prefetched. Because we know that it's not going to be going into the ARC, we can like optimize, reduce the memory copying. Is that?
Yeah, so by default, ARC for any allocations above 4 kilobyte on FreeBSD and above like half kilobyte on Linux, ZFS tries to allocate ABD, which practically chunks it in the 4 kilobyte chunks. So it means we cannot directly map it into DMU cache. It's a trade-off for using more bigger arcs up to like all memory size without KVA contention. But since we know that buffers will be evicted very soon, we can bypass ABD allocation, allocate buffers linearly. It's practically a few line change to make ARC do that. It's trivial. And after that, there are existing code paths already. When we are creating a buffer for debug cache, the code just sees that, okay, we have linear buffer already in ARC, and it just, instead of copying, it just directly maps the buffers, shares the buffer.
Yeah, you get to use that fast path. And this applies only if the data is not compressed. Is that right?
No, yeah, if it's compressed, then if it falls back and uses traditional ABD cache,
okay,
since there is no much place to win. Well, I was thinking maybe I could still use linear buffer if compression algorithm or something would benefit from linear buffer, but I'm not aware about that. So right now, if it sees the buffer is compressed, it immediately fall back to existing behavior. It will still evict the buffer, still beneficial, better than it was before. It still will be prefetch. Just there is practically no extra copy because there is decompression instead.
Yeah, well, actually, I think maybe we do want a linear buffer in that case, because if it is compressed, I'm quite sure we end up copying it to a linear buffer to decompress it, because all the decompression algorithms can't take an ADB. They only take a linear buffer. And so if we skip making an ADB and just always have a linear buffer for the compressed case there, that probably saves a memcopy as well.
So I remember I discussed with people about a compression algorithm, whether we can do compression into a chunked buffer. But if it applies to decompression also, then yeah, probably we could do that.
Yeah, I'm pretty sure right now, if the compressed buffer that we're going to try to decompress is an ABD, we have to linearize it before we feed it to like LZ4 or Z standard to decompress it.
Yeah, I think that's true. But I investigated this several years back, and the performance win that I could get by like not linear, by like keeping it linear, was extremely minimal. I think it has to do with like caching effects.
It probably depends on the cache size and buffer size.
So maybe with record size equals 16 meg, you would see an improvement.
It still should be improvement on memory bandwidth side. So you first copy the additional buffer and then reason from it. But yeah, I should probably profile that. It should be like one line change to allow that.
Right. Yeah, try it out and see if you can get any improvement on the performance there.
And for write, it should always avoid copying, just because we are compressing from already linear buffer.
Yep.
Always, it's just after the writing we're doing compression, copying the ABD. That part I'm skipping.
Cool. Well, that sounds great.
If I understand correctly, the other big win here is before, if you had primary cache equals metadata, you just basically got no prefetch because we had no way to take care of freeing the data before.
Yeah, no, actually, I think I was actually who introduced it years ago. I don't remember how many, maybe 5+ long ago. When I hit that, I blocked prefetcher in that situation. Because like prefetch happens on debuff cache layer, and if we don't have hit on a buffer, then we don't know when to evict. That's why in this patch I made Arc know which buffers are uncacheable and introduced one more cache state for data to be evicted as soon as possible, and they evicted once per second everything that was not prefetched. I was thinking how to call it. I just called evict, but then its state appeared to be called arc evict, and we have function arc evict. That's a bummer. So it ended up arc uncached. But yeah, I benchmarked it on NVMe pool, so the prefetcher less critical, but I'm sure for hard disk pools it should be huge improvements by compensating latencies. And also there, I fixed support for small block, sub-block reads. If you're doing sequential 16K reads, for example, from 128 kilobyte blocks, previously for each read, it reread again from disk. Now it aggregates that, just doing one copy, keeps it in cache for a while. After you read all of them, then evicts. Nice. Again, for it's 16K, maybe a bad example, but if somebody set block size, record size to 16 meg, who knows whether the application reads at 16 meg granularity. So it should be another big win, I think. So just all wins from every side. I need reviewers for that now. So people are welcome.
Cool. Any other questions about the prefetch performance? That's cool. The next thing on the agenda is the Z configuration.
Yeah, so we started a pull request a while back, and it's complete now. So it uses VDEV properties to allow you to configure the ZFS event daemon on Linux to basically control the thresholds of how many checksum or how many IO errors in how much time before we consider a disk to be the source of the problem and offline it and kick in a spare.
Neat.
And because, yeah, right now those values are just hard coded into Z on Linux because it was kind of inherited from the FMA or whatever on Solaris, where there was a system-wide way to configure it. And on Linux, it would just statically set an NV list with those values. But instead now, we get them from per VDEV properties. And we'll have a second pull request shortly that will extend VDEV properties so that the root VDEV, the one with the name and matches the pool name, will also have a zap. It doesn't currently. So like before, it will make a zap if it doesn't exist when we import the pool. And the inheritance we come up with there means that you could set these properties at the pool's VDEV property so that new disks you add will inherit the value you set rather than having to remember to set it on each VDEV as you add and remove VDEVs.
Cool.
And so yeah, just hoping to get some quick review on that to get that merged.
Sounds good. All right, I think that was all of the agenda items on the agenda. Other topics or questions today?
Pavel and I have been looking at one of the things we talked about at the Dev Summit, the doing IO rate limiting per data set, and trying to think through which thing you would actually want to be limiting. For example, if you want to just limit the read megabytes per second per a data set, would that be at the top layer, like the ZPL, where you're saying the read and write calls we get from the application, we're limiting that, or do we want to look lower and be like, just because you did a 4K read doesn't mean that it didn't actually generate a lot more reads from the hardware, right? If the record size is larger, then your 4K read maybe pulled a whole 128K off disk, and then what about all the metadata? And
yeah, well, even ignoring that, like caching would have a big effect on that. Like if the data is cached, then it would count at the ZPL level, but not actually doing any IO to disk.
Right. And kind of just like quotas with compression, it's a question of, in that case, should that be the provider's gain, that the fact that they managed to get it cached for you and you get the throughput that you were told you would get anyway? Or in some of those cases is like, should the user get the win, the fact that what they're requesting was already in cache? And yeah, we're definitely interested in what other people's opinions on that type of thing are.
So I can share about my thinking on this topic. So in my opinion, we should provide something which is predictable. So either we should be consistent and just limit the application traffic, or try to limit like the disk traffic, which is, but when we go to disk traffic, extremely hard to, this won't be predictable for the user, because we have to then account for all the inflation related to like rate Z, all kinds of even like metadata traffic and stuff like that. So even if you do like small request, it can be inflated, and it's hard to like predict by the application or by the user how much throughput you will use, etc. On the other hand, when we measure the application throughput, of course, it won't be reflected in this traffic, because again, there's a lot of factors. But I think that we shouldn't try to do something in the middle. So let's say we monitor, because doing this on application, like trying to monitor application traffic, so monitoring just read, write system calls or VOPs, we basically it's more predictable for the user. Let's say I will use dtrace to monitor my application, so I can see, okay, I have this limit and it matches what I get from the application. If we will try to do something in the middle, so let's say we do small read, but we know it will be turned into whole record size read, so we try to inflate that and account for that, then for me as the user, it's hard to predict what's my limit exactly. So yes, so I think our conclusion was to just monitor this at the VOP level and basically limit the application traffic and not try to limit disk traffic, which could be much harder. And also it's much harder for other reasons, because we are already too late, like it's already in transaction group, so we may not be able to actually delay some of those requests. So we would need to, like, I don't know, somehow penalize the application later. So it's getting messy.
Yeah, for writes, for async writes, that seems very difficult.
Yeah.
Yeah, and just, you know, once all the writes are mixed together into a transaction group, we can't make some of them slower and not end up delaying others and so on. And yeah, like we kind of looked at trying to do it completely logical, like the logical data, or completely physical. But even on the writes, it's like the ideal place to rate limit stuff there is in like the TXG try assign or whatever it's called, before it's in the transaction group, where we do the throttling for dirty data and so on, because other throttling already takes place there and it makes sense. But you know, that's not, at that point, we don't know how much actual physical IO this ZIO is going to cause. And so we can't actually tune the limit there. And yeah, like Pavel said, even when we looked at trying to just guess and be like, oh, you're doing the ZIO, and we happen to know that the record size for this object is 128K, so we're going to round your read request up. It gets very confusing to the user when their performance kind of skips all over the place, versus if they just get, you know, the solid 500 IOPS that their quota is set to, then that seems maybe not as ideal for load balancing, but much more predictable and easy to reason about from both the user and the administrator's point of view.
Yeah, and there's a lot of things we cannot predict, like NOP writes, compression, and stuff like this. So yeah, but I think from the user's perspective, it would be good to know, like, okay, I can verify that. I can, let's say, use dtrace and see, okay, that's my application throughput or IOPS or whatever. So this is the limit I will put. So because this is my normal workload, let's say.
Right, and with doing it logically, it would map directly to the per dataset K stats that we have now for the reads and writes and the IOs there. And so,
any, if we're talking about doing it at the ZPL layer, then you could also do it at the VFS layer, like, and have this work for other file systems, but it would probably be an implementation that's specific to your operating system. I was wondering, does anybody know of like this being done on other operating systems?
So
like,
there is one at the VFS layer in FreeBSD called RCTL for resource control.
But from our experiments, it doesn't work well. It's
no.
way of.
Well, especially it tries to do things like limit CPU, and it leads to all the people using up all their CPU quota in the first couple of milliseconds of the second, and then everybody waiting, and causes really weird load effects and so on. But in this case, the target for this work is Linux. But
in terms of like doing this at VFS, of course, that this could be done. But one of the arguments to do it in ZFS is that we could get this inheritance. So
Yeah.
which we.
I'm not saying we shouldn't do it in ZFS. I was just kind of like, in terms of the landscape of what other options there are, and then comparing kind of how those are controlled and how they're used. Like, are they used a lot? It sounds like the one on there is one on FreeBSD, but it doesn't work very well, so maybe nobody uses it. So looking at like why that doesn't work well and trying to improve on it, or if there's something like that is used, then but we want to do a better version of it, like hooking existing applications like or administration tools into our new thing would be helpful.
Also, if we do it at the ZPL level, well, we want to start from like limiting the data traffic, but I also can imagine that we would like to add along the way limiting metadata traffic. So all the like
file creation, rename.
Right, like I'd imagine maybe we can't charge you the bytes that it would cost to do a stat or an mkdir, but we can definitely charge you an IOP for it every time.
Yeah.
Yes. So with all of those, we could have like total counters, right? That limit. So, for example, I don't really care if those are reads, writes, or stats or whatever. I just care that I don't want more than this amount of file system operations, right? Or something like this.
But yeah, we were just interested in anybody else's thoughts on, their use case for this, and, practical considerations as far as being able to make this useful to beyond just the scope that we have for the first customer.
Hey everybody, it's first time showing up here. I've been using ZFS for about a decade at UCSF, running lots of servers, lots of petabytes. My use case would much more fit the model if I'd want to prioritize data sets, and so rather than limit total IOPS, I would if the system isn't busy, I want to give as many IOPS as possible to whoever wants it, right? That's my business. And so a model where you're prioritizing what's coming in, and so filling a transaction group, maybe I could say 40%, almost like nicing, right? So 40% would go to the highest level if there's contention, 30% the middle level, 20% lowest level priority. Just something like that might fit better in terms of how I would sell this to my customers. So that's just all I can provide in terms of feedback about kind of usability or value to me.
Mm-hmm. Yeah, we've had similar thoughts about, relative priorities and so on, although I'm not sure how you would express that in a way that would scale to, a large number of data sets or users.
Yes, like with this kind of architecture, we would need to definitely, the model would be definitely much more complex in order to monitor like the whole pool globally and know exactly what's going on in all data sets, and try to like based on this knowledge then limit resources for each data set based on priority. It just much more complex basically, but not impossible, I guess.
Yeah. No, it definitely, as I was thinking about it, I was thinking it more as like nicing. So it's just, it's it's going to be a relative priority group, right? And so everything that's coming in that's above a certain threshold, essentially comes in through one slot.
But just so we understand the consequence on doing this at the ZPL layer. So when we limit the throughput or IOs or basically operations, we have no idea if this can be actually consumed by the pool or not, right? So we don't have this knowledge. We have no idea if our read will turn into multiple reads or our write will turn into multiple writes, etc. So we cannot. So we can easily send too much or too little, but and it's hard to tell. So in ZFS there is already throttling to provide this back pressure if we just try to send too much, but it's not based on priority of the data set. But for this it would be hard because we don't really know the pool limits. And we don't really know how our application level traffic translates to disk traffic. So
right, like Matt said, if it's a cache hit, it turns out it doesn't generate any disk IO. But later it might.
From that perspective, I think it would be more useful to track from the original separation between application stats and disk stats. I think we obviously need to get closer to disks, but I'm thinking, for example, in case of reads, if somebody tries to do more IOs than he has guarantees for quality of service for, we could just mark those IOs as lower priority, just introduce some priority levels or somehow else move it to the IOs to scheduler, to zero scheduler, and in that layer deprioritize them to run slower. For write, obviously, it would be more complicated, but then again, we have our throttling mechanism, which right now based only on the size of the amount of dirty data in ARC. And we already have a problem if we have two applications running, one in bigger blocks, one in smaller blocks. The smaller one will be much heavier penalized than bigger blocks. We already need some sort of redesign there. So if we could add into the same function, returning delay time, add additional factors, not just all buffers are put into the same linear queue, and then respectively wait for the time. Maybe we could then just depending on priority, depending on how much user written in a previous X seconds, minutes, whatever, you get different coefficients in that function. So we still get full throughput of the disk. So we will always get the same amount of dirty ARC. It's just somebody with lower priority who already went over the quota can get throttled heavier.
So instead of a quota, make it more like a reservation where
exactly.
The first X IOPS that you do go through at the normal priority, but anything over that gets deprioritized.
No, so that's what cellular operators do. That I guess that's everybody who wants to not just limit somebody's streak, but do some fair share. That's the approach. I'm not sure what's the point of giving exactly X megabyte per second if we still have bandwidth and it's idle. Why not? Because we have some background processes like Scrub, but maybe we could account that somehow too.
That's an interesting, slightly different take on it, where we just flag it as lower priority and rather than stalling it. Although I guess it means coming up with more queuing mechanisms at the ZIO level to sort in and prioritize the ZIOs, although I can see where that'd be useful in a couple different places as well.
How were you guys, what use case were you thinking of for the strict quota, which is
basically
easiest to implement?
Right, multi-tenant thing, a bunch of different LXD containers basically, and wanting to make sure that one noisy neighbor doesn't kill everybody. And just to keep it simple, we'll just set a megabytes per second and an IOPS per second limit on each of them, and that'll keep any one person from dominating the system too much. And not too worried about fair share or anything, just that one person doesn't make it terrible for everyone.
And so you would you would kind of have a rough guess of well, I know that, the system can sort of do 2 gigabytes per second of IO, and I have 100, clients, and so I'm going to oversubscribe 10x maybe. So I'm going to give them each
each one gets 50 megabytes a second or something.
10 meg per second or whatever. Yeah. So it'd be very kind of hand wavy, and you could, you get into situations where you can't get your whole quota because it's oversubscribed by everyone else. You get into situations where the system's underutilized because a few people are hitting their quotas and nobody else is using it. But for your use case, those are all kind of fine.
Yeah. And the goal was to not make it overly complicated where it's going to take too long to build. Although maybe doing it more like a reservation rather than a quota where, when you go over, you just deprioritize instead, maybe isn't making it too much more complicated.
Yeah,
maybe it depends on what the queuing looks like.
Yeah, it depends on how they're deprioritized exactly. But that does seem like a not too hard way to describe what you want.
But we could deprioritize, from what I understand, the reads, right? Right. But can we do that the same with writes?
With writes, I think maybe we can do something like, don't assign it to the transaction group if there's anything else outstanding still or something. Maybe not easily.
It's hard to
so then it's quota, right? If you don't assign to the transaction group.
Or it's you get really super slowed down, where if you're not getting assigned to the TXG until the next TXG, or it ends up very hacky where you can do something oh, if the TXG is at more than 50% of the max dirty data, then I'm not going to add any more of your IOs or something like that. But I think it'd be hard to come up with anything that has kind of consistent performance.
Yeah, that happens. Well, if we're prioritizing as we work through the list of ZIOs, then if we're getting to assigning to it to the transaction we've already.
For writes, you don't have the ZIOs.
Right.
Until you're in seeking context,
you've actually
already
built
committed
them,
to doing all of that stuff. Yeah. You could sort of you could do it much better for synchronous writes.
Right.
Because synchronous writes, at least some sort of IO has to happen in open context.
Yeah, but I wonder if we cannot do that for all kinds of IOs, if it makes sense to do it at all. Because if we will do it for most of the IOs, but still async writes, we cannot really address them, and one consumer still can send a lot of writes and just saturate the pool, then reprioritizing the rest, I don't know, it doesn't really address the problem. So underutilizing the pool, that's real concern. And I wonder if this is not just a balance of being able to utilize the pool fully and being able to provide predictability to all the tenants on the system.
As I've told, I think the most realistic way to do it on a dirty buffer throttling place is just currently it's throttling all done in one sequential queue. If we could somehow split it, that single queue between several, what we call consumers, some entities who should be applications that should be balanced. Okay, your specific whatever client consumed 10% of dirty arg buffers, start throttling or something like that. Like maybe implement 2 separate throttlings, one system-wide just to not overflow the memory, and one more user specific, which start throttling earlier when it got 10% of dirty buffers consumed just by itself. So if nobody else uses the pool, it will still get most of throughput, or at least not 100%, depending on how tight do we limit it and pool characteristics, but most of pool bandwidth. But if there will be other users who will push data into Arc more actively, this one will obviously get penalized heavier. Just question how to turn it into exact numbers, coefficients and so on, but
having those queues like per data set seems a bit
well, what granularity of all these quotas we are discussing that are expected? Is it data set or
is data
else?
set?
Yeah.
Although with inheritance, like disk quotas, basically, where if you set a quota on the parent, then the children have to respect that quota as well.
And that's actually one of log contentions I saw on my benchmarks, the higher ops. So yeah, something better would be good.
Mm-hmm.
Yes, so we are considering like not doing inheritance initially, but of course it would be nice if you could have like a, let's say, group of customers that have some kind of quota, and then each customer have smaller individual quota, but you can do over provisioning in this just for this group of customers. So and of course all the data sets created below for this customer are treated as one, basically, with a single limit. But doing this at the for data set instead of like process or user, or actually remove some problems. Let's say that you would like to slow down withholding range locks on files. This should be okay because all the customers of all the users of those files needs to be slowed down. If we would do the limiting like per UID or per jail or something like this, and potentially you can have users with different limits trying to access the same file, then you have to do slowdown differently. But if you do it like this, then yeah, you have to you can easily slow down all the consumers of the file because it's based on data set limit.
Mm-hmm.
Yeah, seems like a tricky problem overall.
Yeah.
Yes, it is a tricky problem, and actually based on some of the attempts like in FreeBSD with RCTL, I think it's I personally would prefer to have like something which is predictable, measurable, like something that I can easily figure out or test. If I set this limit, I know what exactly does it mean.
Yeah. Because I think especially from the administrator or user's point of view, getting random speed ups or slowdowns because of things you don't control, like the right amplification or metadata or caching, or even compression, is probably quite confusing versus And I think in most cases of a multi-tenant situation where, you know, the provider is doing this, they would like to keep the wins from compression and caching to themselves to get more over provisioning or whatever, rather than necessarily pass those on to the customer.
Yeah, so I mean, maybe the next steps for this are to write up like what exactly you would propose. I mean, I like the idea of coming up with something that's like maybe not the best thing that we could imagine, but something that is easy enough to understand and easy enough to implement that it's useful. And then maybe getting feedback on, is this really useful, right? Because we can build something simple, but if people don't use it because it's not really what they want, then it wasn't really that useful, right? Like some people might have a hard requirement of like, I need to be able to get the full, like if I'm the only user, I need to get the full throughput of the system. Like if there's no contention, then I should have the same performance as I did before. And that's kind of a different requirement versus like what you're talking about, where you would just set a quota on each user or each data set.
Right. Yeah, definitely interested in feedback from more people to see how we can both keep it simple and useful.
Cool. Any other topics for today?
It's me, Tino here from Germany. I just wanted also some feedback for my pull request for the SHA-2 reworking. The benchmark numbers are nice, and I don't get any reviews. I have no plan what to do next. It's a bit more, it's about 60 files, so it's difficult to keep it always rebased. It's maybe you can take a fast look and assign some.
Yeah, I just looked at the numbers in your PR. I mean, the numbers all look good. Thanks for gathering all that data on those different systems. Is the old implement, so that you're changing the implementation of SHA-2, which is used by the SHA-256 and SHA-512 compression, checksum algorithms. Is that right?
Yes, this is the request. I put a link into the meeting chat, and you will get the benchmark numbers on top of the pull request. And the numbers are on an AMD Ryzen system, on some Intel system, and an Mac Mini M1. When you scroll down, also RINS did some more tests and so on. It works. It's all OpenSSL code, Apache license. The old assembly stuff is also OpenSSL. So I think it should be okay, but I don't get any review or some more comments on it. So I just want to ask.
Yeah, it looked like Rich took a look at it a while back, right? Rich Ercolani.
That was the first thing, maybe. The real implementation was done, I think, in September. Before this, there were some points that needs fixed, and these are fixed currently. So the tests from the CI are always okay, I think, in the last time.
Yeah, I think we need to figure out like what review, like
This
what,
review needs a lot of time, I think, but maybe some more time. So it's not for 5 minutes now, but I just wanted to call.
yeah. And I think we should try to figure out like what level of review do we want to see for this. You know, there's 28,000 lines of code. Presumably most of that is the stuff that you just copied over from OpenSSL,
OpenSSL.
right?
Yes.
I don't think that we're going to review that. So I mean, in my opinion, I'm kind of like, that's fine. We'll just trust that they did it right. Like that's obviously used even more heavily than ZFS is. So we should review like the infrastructure stuff. You said that you changed some of the interfaces.
Yes.
So we should take a look at that. I'm just kind of skimming through the code to see, you know, it doesn't look like there's a ton of that. I use the SHA stuff, yeah. So I mean, I think it's not a tremendous amount of work to review this. We just need to find folks who are interested in, you know, the checksum algorithm stuff. Let's take a look. I haven't looked at this stuff in a long time, but I think that I'll definitely ask someone to, maybe Mark, to bug people about code reviewing. It looks like we have a couple of candidates, Rich, and I see comments from one other person. Oh yeah, Sebastian, Brainslayer. We can ping them.
He uses it already in DDWRT. It's a router-based system for ARM 7, I think.
Yeah, I think him and I think Rich would probably be able to do a good job on this. I know he's done a lot of work on the compression algorithms, and he might be interested in this as well.
Okay, just wanted to ask.
Yeah, thanks a lot for this work. I think, are there before and after to see?
You can look before when you take the benchmark numbers of the break 3 hash supporting stuff. Moment, I can put it on.
Just because that might help to motivate people if they can see like, oh, you know, this actually improves performance or on certain things.
Yes, a lot.
Because I don't remember the SHA-NI stuff. Is that new? Oh yeah, right. So
that one depends on the CPU having the instruction.
Yeah, but I thought that we didn't have that before.
So before and after, I just put a link for the break 3 thing, which got merged. There, the SHA hashes are benchmarked also, and this is the old implementation, of course. And then you can, yes, see the difference, of course.
So in the old one, it has the SHA-256 and SHA-512 generic, but not the optimized ones. Are all of those optimized ones new, or did some of those exist before?
They are all new. The old one got only some OpenSSL generic optimization for I think only 64-bit systems. Intel.
All right, so basically this is, you know, we can think of this as adding the what do we call it? Not SSE, but vectorized, adding the vectorized instruction optimized versions of SHA-256 and SHA-512
Yes.
for
For a lot of platforms, of course.
Yeah. for a lot of platforms, including, the AVX, the SHA-NI, and the ARMv8 CE stuff, which looks like great performance.
Also Power 8 and so on are implemented.
Oh, cool. So yeah, I think that's a huge performance win for folks who are using SHA-256 or 512 on those platforms, which are, the most commonly used platforms. So I think maybe we can try to highlight that performance improvement to motivate folks, like, hey, we need code reviews so we can get this in, so we can get, what is it like?
I put the win on top.
More than
I
5x performance win.
know what I could make better. I put the winnings on top of my pull request, so I think it's okay this way for motivating other people.
Cool.
Okay.
All right, thanks. I think we're almost out of time. Any volunteers? Or I'll just hope that I can bug Rich into doing it. He's not here to defend himself, so. All right, cool, thanks. Any other topics as we wrap up the meeting today? All right, then I'll see you all in 4 weeks, which is after the new year, just after the new year, January 3rd. See you then. Bye.
Bye.